There's a moon in our solar system with rain, rivers, canyons carved by flowing liquid, and seas deep enough to swallow a ship, and not a single drop of it is water. Every river on Titan runs with liquid methane, the same compound you burn on a kitchen stove, kept liquid by cold so extreme it would crack steel. The methane, we understand. But when the James Webb Space Telescope read the light coming off this world, it detected something else sitting on that frozen surface. A second substance that matches nothing, not one entry, in humanity's entire chemical library. Let's go back to where it all began, because Titan has been keeping secrets longer than almost any world we know. Like, comment, and subscribe for more videos like this. Now, on the night of March 25, 1655, a Dutch astronomer named Christian Huygens pointed a homemade telescope at Saturn and noticed a faint star that didn't behave like a star. Night after night, it moved with the planet. Huygens had found Saturn's largest moon, a world that would carry his name to its surface 3.5 centuries later, in a way he never could have imagined. For nearly 300 years after that, Titan was nothing more than a point of light. Then, in 1944, the astronomer Gerard Kuiper passed that point of light through a spectrograph and found something no moon was supposed to have: an atmosphere, thick with methane. Every other moon in the solar system is naked rock or ice, exposed directly to space. Titan somehow had weather. That single measurement changed the course of space exploration, and it cost us a planet. In November of 1980, NASA's Voyager 1 spacecraft reached Saturn with a choice to make. One trajectory would have slung it onward toward Pluto, the last unexplored planet. The other bent the spacecraft's path down toward Titan for a close flyby, a maneuver that would fling it up and out of the plane of the solar system forever, with nowhere left to go. NASA chose Titan. That's how much this moon mattered. The agency traded humanity's only shot at Pluto for decades just to get one close look at it. And here's the painful part. Voyager 1 saw almost nothing. When the images came back, Titan was a featureless orange ball, a smog of hydrocarbon haze so thick that no camera could punch through it. The spacecraft measured the atmosphere and confirmed it was mostly nitrogen, like Earth's, with a surface pressure 50% higher than what you're sitting in right now. But the surface itself, the thing everyone wanted to see, stayed completely hidden. Voyager 1 gave up Pluto for a moon that refused to show its face. It took a quarter century to get back. In 2004, the Cassini spacecraft arrived at Saturn carrying a passenger, a European-built probe named Huygens, after the man who found Titan in the first place. On January 14th of 2005, that probe detached, fell through the orange haze for 2.5 hours, and landed. It remains, to this day, the most distant landing in human history, farther than any machine has ever touched down, before or since. On the way down, its cameras finally saw what the haze had been hiding: river channels branching like veins across the landscape, shorelines, drainage basins, the unmistakable fingerprints of flowing liquid on a world where the temperature sits near 290 degrees below zero Fahrenheit. The probe came to rest on a floodplain scattered with rounded pebbles, the kind of stones you'd find in a creek bed on Earth. Except these pebbles were made of water ice, frozen harder than granite, and the creek that rounded them had been liquid methane. Over the next 13 years, Cassini flew past Titan 127 times, using radar to map the surface strip by strip. What emerged was a world running a complete weather cycle: evaporation, clouds, rain, rivers, and seas, with methane playing every role that water plays on Earth. Near the North Pole, radar revealed enormous bodies of liquid. The largest, Kraken Mare, stretches roughly 1,000 kilometers across, bigger than all 5 of North America's Great Lakes combined, with depths measured in the hundreds of feet. In 2017, its fuel exhausted, Cassini was deliberately flown into Saturn's atmosphere and destroyed, partly to protect Titan itself from any chance of contamination. The mission ended. The close-up era was over. Whatever questions remained would have to be answered from Earth, a billion miles away. That's exactly where the James Webb Space Telescope enters this story. Because Webb doesn't need to fly anywhere. It reads light itself, splitting it into thousands of individual wavelengths and finding the precise chemical fingerprint of whatever it stares at. Every molecule in the universe absorbs light at its own specific wavelengths, as unique as a signature. Build an instrument sensitive enough, and a pinprick of reflected sunlight from a billion miles away becomes a full chemical inventory. And Webb has one advantage over every telescope that came before it. Titan's haze, opaque to visible light, turns partially transparent in the infrared. Webb sees in exactly the wavelengths where Titan's mask slips. In November of 2022, Webb turned toward Titan for the first time, and the very first images caught the moon in the act. A team led by planetary scientist Connor Nixon at NASA's Goddard Space Flight Center spotted two bright clouds drifting through Titan's northern hemisphere, and one of them was hovering directly over Kraken Mare, the largest sea. The team alerted colleagues at the Keck Observatory in Hawaii, which re-observed Titan days later and caught the clouds again. They'd moved, they'd evolved, but they were there. For the first time, astronomers were watching weather develop on Titan from Earth, confirming that its northern summer was stirring the atmosphere exactly where the seas could feed clouds with evaporating methane. Webb's first look, and Titan was already performing. But clouds were just the opening act. The discoveries that followed are the reason this video exists, and each one is stranger than the last. The first came from deep inside Titan's chemistry. In 2025, Nixon's team published something in the journal Nature Astronomy that had never been achieved before. Using Webb together with Keck, they detected the methyl radical, CH3, floating free in Titan's atmosphere. That name may not sound dramatic, so here's what it actually means. When sunlight and charged particles from Saturn's magnetic field strike Titan's upper atmosphere, they tear methane molecules apart. The fragments, including that methyl radical, then recombine into heavier and heavier compounds, ethane, benzene, and eventually the complex orange smog particles that hide the surface. Scientists had always known this chemical assembly line must exist. They could see its raw material, and they could see its finished products. What they'd never seen was the assembly line actually running. The methyl radical is a molecule captured mid-reaction, torn apart but not yet rebuilt. One researcher compared it to seeing the ingredients of a cake laid out on the counter, mid-recipe, instead of just the cake. Webb caught Titan's chemical engine with its hood open, live, and that detection sharpened one of the most uncomfortable numbers in planetary science. The destruction of methane on Titan is a one-way process. Every methane molecule the sun tears apart is gone for good, converted into heavier chemistry that rains down and stays down. At the measured rate, Titan's entire atmospheric methane supply should be destroyed in a few tens of millions of years. That sounds like a long time, but Titan is 4.5 billion years old. It's the equivalent of finding a candle that should have burned out ages ago, still lit. Either we're witnessing Titan in a rare, temporary phase, watching its rivers and seas in the final 1% of their existence, a coincidence almost too lucky to accept, or something inside the moon is quietly resupplying the methane. Reservoirs in the crust, ice volcanoes. Some process no one has identified. There's no confirmed answer. The seas of Titan are either dying in front of us or being secretly refilled from below. On June 11th, a research team uploaded a study to the preprint server archive describing something they'd found in Webb's spectra of Titan. In a stretch of the infrared spectrum that earlier instruments had never been able to explore in detail, the region around 5 microns, the light coming off Titan's surface, had a gap in it. A dark notch, centered at 5.11 micrometers. Something on the surface of Titan is absorbing light at exactly that wavelength and swallowing it. The routine next step is to check that notch against the spectral libraries, the accumulated catalog of every compound humanity has ever measured, in laboratories and across the solar system. The team checked ethane, ethylene, acetylene, propane, benzene, hydrogen cyanide, every hydrocarbon and nitrile already confirmed on Titan, and in the team's own words, they did not find any previously published band that corresponds to this absorption. Nothing matched. There's a measurable, repeatable signal coming off the surface of Titan, produced by a substance that doesn't correspond to any confirmed molecule in the record. And here's the part that turns a curiosity into a real mystery. Titan is not the only world showing it. The same team found the same absorption at the same 5.11 micrometer position in Webb spectra of Pluto. And on Pluto, the feature is roughly 3 times stronger, which means whatever produces it is far more abundant there. Think about what those two worlds have in common, because it's almost nothing. Titan orbits Saturn, wrapped in an atmosphere thicker than Earth's, with sunlight 100 times stronger than what reaches Pluto, and lakes of liquid sitting on its surface. Pluto is a frozen dwarf planet in the outer darkness, with an atmosphere 100,000 times thinner than ours. Different sizes, different temperatures, different histories, different regions of the solar system entirely. Yet both are coated in something that absorbs the same slice of infrared light, and that substance has no name. There's a further wrinkle in the data. On Titan, according to the preprint, the signal isn't spread evenly. It shows up stronger on one hemisphere than the other. Patterns like that usually mean a process is at work, something being manufactured, transported, and deposited unevenly, rather than a simple ingredient scattered at random. The researchers have proposed candidates. It could be benzene locked together with some unidentified partner molecule. It could be an exotic ice of acetylene or ketene. A family of hydrocarbons called allenes absorbs light near this region and hasn't been ruled out. But every candidate has a problem, and the authors are unusually direct about it. Much more work is needed before anyone can claim an identification. This result is also still a preprint, shared ahead of formal peer review, which means it's an active investigation, not a settled fact. That's not a weakness of the story. That's what science looks like while it's happening. But sit with the most likely explanation for a moment, because it's bigger than either world. If the same unknown substance really is forming on both Titan and Pluto, then there's a chemical process operating across the outer solar system. Take nitrogen, take methane, add sunlight, even the faintest trickle of it, and the universe reliably manufactures something we've never identified. 2 wildly different worlds running the same hidden recipe. And beyond Neptune, there are tens of thousands of cold, nitrogen and methane-rich bodies we've never examined this closely. Titan and Pluto may simply be the 2 places we happen to look. Now, imagine you are actually standing there, because the strangeness of Titan is easiest to feel from the ground. You're on the shore of Kraken Mare. The gravity pulling on you is 1/7 of Earth's. You weigh less than a toddler does back home. The air around you is half again thicker than Earth's, thick enough that if you strapped wings to your arms and flapped, you could fly under your own muscle power. Titan is the only world we know of where a human being could do that. The sky above you is a deep orange murk, and the daylight filtering through it is a few hundred times dimmer than an Earth afternoon, a permanent amber dusk. Somewhere above that haze hangs Saturn, its rings spanning a stretch of sky wider than 20 of our full moons, and you will never see it. The smog never opens. If rain comes, it falls in methane drops nearly twice the size of raindrops on Earth, drifting down at the pace of falling snowflakes in the low gravity, taking long minutes to reach the ground. The sea in front of you is glass-dark liquid methane at 290 degrees below zero. The beach under your boots is water ice, frozen so hard it rings like stone, and mixed into it, everywhere, is a substance chemists cannot name. You're standing on the mystery. And beneath all of it, there's one more layer. Measurements from Cassini revealed that Titan's crust flexes as it orbits Saturn, deforming far too much for a moon of solid ice. The best explanation is a global ocean of liquid water, buried maybe 60 miles down, wrapped around the entire moon beneath the frozen shell, which means Titan is layered like nothing else we know. A surface chemistry factory producing complex organic molecules on top, and a hidden water ocean below. The two ingredients of biology, stacked on the same world, separated by a wall of ice. That's why researchers keep coming back to one comparison. Before oxygen existed on Earth, before photosynthesis rewrote our air, this planet's atmosphere was dominated by nitrogen and simple carbon compounds, with complex organic chemistry cooking in the haze. That era ended here billions of years ago, and it left almost no direct evidence behind. Titan is running a version of that chemistry right now, at planetary scale, in real time. It may be the closest thing that exists to a working model of the world that life first emerged from. And it's producing at least one compound we can't identify, which is exactly why NASA is going back, and this time, with something unprecedented. In 2028, an 8-rotor robotic aircraft called Dragonfly is scheduled to launch toward Titan, arriving in 2034. Not a rover, an aircraft. Titan's thick air and weak gravity make it the easiest world in the solar system to fly on, and Dragonfly will exploit that, leapfrogging miles at a time between landing sites, powered by a nuclear generator, sampling the surface at each stop. It carries instruments that can identify surface compounds directly, touching the actual material instead of reading its light from a billion miles away. If the substance behind that 5.11 micrometer signal is common on Titan's surface, Dragonfly may land on it, drill into it, and finally give it a name. And because Pluto carries the same signature, whatever Dragonfly learns on Titan will solve a mystery on a world 3 billion miles beyond it. One landing, two answers. So step back and look at what Titan actually is now. A moon that cost us Pluto in 1980 and hid behind its smog for another 25 years. A world with seas that are either dying or being secretly refilled, and nobody knows which. An atmosphere whose chemical engine Webb has finally caught running, molecule by molecule. A surface carrying an unidentified substance it somehow shares with Pluto across 3 billion miles of empty space. And underneath everything, an ocean of liquid water that has never seen light. Every time our instruments improve, Titan gets stranger. There's no reason to believe that pattern stops here. Webb returns to Titan again and again. Every pass adds new spectra, and teams are already hunting for that same unnamed signature on other cold worlds, including Neptune's moon Triton. And in 2034, Dragonfly starts flying. If you want the answer the moment it exists, when that molecule finally gets a name, subscribe and turn on notifications, because this channel will break it down the day it happens. And drop a comment with your theory. What do you think is coating the surfaces of Titan and Pluto? Scientists don't know yet. Your guess is currently competing with theirs. Thanks for watching, and I'll see you in the next one.